Question 63. Base your answers to question 63 to 65 on the chart below, which shows some physical properties of minerals and definitions of these properties. Letters A, B, and C. Over here you have an A, over here you have a B, over here you have a C. Indicate parts of the chart that have been left blank. Means been left blank on purpose for you to fill it in. Letter C, that's over here, represents the name of a mineral. Now for question 63, which physical property of a mineral is represented by letter A? Well, you have some physical properties of minerals. You have hardness, you have streak. There's another thing that's called luster. But let's see what each one says what it means. Over here it says A means the way a mineral reflects light. Well, luster is the way a mineral reflects light. So the question is, which physical property of a mineral is represented by A? The answer is luster. L-U-S-T-E-R. Luster. Question 64. State the definition represented by letter B. Well, it says each thing. It gives you hardness, which means how easily a mineral is scratched. Luster, which means the way mineral reflects light. And streak, which means, if you remember learning, streak means the color of the dust or powder left when a mineral is rubbed against a hard, rough surface, such as an unglazed porcelain tile. It means when you scratch it across a porcelain tile, so you can see the luster, you can see the color of the Question 64. State the definition represented by letter B. Well, we know hardness means how easily a mineral is scratched. Luster means the way a mineral reflects light. And streak means the color of the powder or dust of a mineral. That's the answer to 64. B represents the color of the powder or dust of the mineral. When you scratch it against the porcelain plane, you find out the color. There will be powder because if the porcelain plane has bumps on it, it's a scratched plane. When you push the mineral across there, and you hold onto the mineral and you push it across the plane, it will powder or dust will come off, and the color of this powder or dust of that mineral is called the mineral's luster, the mineral streak. Question 64. State the definition represented by B. Well, streak means the color of the powder or dust of a mineral. When you're scratching to see to get off some powder or dust of a mineral, you scratch a mineral across a porcelain plane and out comes some powder or some dust. So the color of the powder or the dust of the mineral is called the mineral streak. That's the streak, which means the color of the powder or dust of a mineral. Question 65. Identify one mineral that could be represented by letter C. See, I erased the board. I just left the part of the diagram that said hardness. So hardness, which means how easily a mineral is scratched. Example C, which scratches olivine. So it says C scratches olivine, and it asks us to tell us what C is. Well, it asks which mineral could be represented by C. So anything that scratches olivine could be C. So you have to look at the diagram you have properties of common minerals. And if you look over there, you'll see that if you go up and down hardness, so you see it says hardness over here, that means you check the hardness chart. And when one has a higher number of hardness than the other, that means the one with a higher number of hardness could scratch one with less hardness. like a knife, a rock is much harder than, let's say a knife. A knife, metal, is much harder than, let's say, a piece of paper. So a knife could cut paper, a knife could cut other things. So olivine, it shows that it has a hardness of 6.5. If you look up and down, you'll see that it shows you quartz and garnet has a hardness of 7. So I ask you what C could be. It's something that scratches olivine. The answer is quartz or garnet. However, you could have also said anything that's greater than that 6.5 or greater. So topaz is 8, has a hardness of 8. Corundum, ruby, and sapphire have a hardness of 9. Now remember, corundum is 9. Carborundum is 9.5. And diamond is 10, meaning it's the hardest. They use diamond to cut diamond. How do you cut a diamond? It's so hard. The answer is they use diamond to cut diamond. So anyways, any of these would have been the right answer. But it's better to go according to your charts. And in your charts, it says quartz and garnet are 7. So what could be represented by C? C is something that scratches olivine. So if you looked at your chart of properties of common minerals, you saw that was 6.5 olivine. So something that could scratch that is something that's 7. And 7 or above, 6.5 or above. So all you have to write is quartz, or you can also write garnet. And that's the answer. Question 66. First, from question 66 to 85, put all answers in the space provided. Now, base your answers to question 66 through 69 on the diagram below, which shows the moon's orbit around the Earth. This is the Earth. This is the North Pole. These are the sun's rays. So that's why this side of the Earth is light, but the sun's rays are blocked by this part of the Earth, so the sun's rays don't go onto the second half of the Earth. The second half of the Earth is dark. This is the North Pole, and this is one half of the Earth is being lit up. It's day, and the other half is night. Now, and this is the orbit of the moon around the Earth. Question 66. On the diagram above, place a small circle on the moon's orbit at the new moon phase where none of the lighted portion of the moon is visible from Earth. Luckily over here they give you two things of information that should help you. First of all, they say place a circle on the moon's orbit at the new moon phase. The new moon phase is where none of the lighted portion of the moon is visible from the Earth. But question 66. Anyways, from question 66 till question 85, put all answers in the space provided. Base your answers to question 66 through 69 on the diagram below, which shows the moon's orbit around the Earth. This is the sun's rays coming from here. This is the Earth. The middle is the North Pole. The clear side is the daytime because the sun is shining on it. And the side with the lines on your test will just be dark. That's the nighttime, because the sun's rays are not shining on it, because the sun is not on this side, the sun is on this side. It's shining from this way. So, and this is the moon's orbit around the Earth. Now, question 66. On the diagram above, place a small circle on the moon's orbit at the new moon phase where none of the lighted portion of the moon is visible from the Earth. So, where is it a new moon where none of the where none of the lighted portion of the moon is visible by the earth? Well, just like over here, if let's say the moon would be over here, right? Let's say it's this over here. The moon would be over here, so then the moon will not see this part of the earth, which is light. Same thing, if the moon would be over here, then the earth will not see the lighted part of the moon, because the lighted part of the moon will be facing the sun, and the dark part of the moon will be facing the earth. So place a small circle on the moon's orbit at the new moon phase where none of the lighted portion of the moon is visible by the earth. That's right over here. This is the earth, straight towards the sun. In the middle of it, put a circle, and that's the answer to question 66, because the sun rays are going on this side of the circle, and the dark side is facing the earth. The dark side of the moon is facing the earth over here, and therefore none of the light portion of the moon is visible from the earth. So this little circle is your answer, right over here. Put it up here, it's no good, because the earth could see a little bit. Put it down here, it's no good, and over here, it's all of the moon's light will be seen by the earth. So this is the only correct answer, the circle over here. Question 67. Explain why ocean tides are cyclic. So, what is cyclic? Cyclic is a recurring round of operations or events. For example, the earth, sun, and the moon affect the tides. The sun, when the sun is in one place of the sky, the tides are being pulled in one direction. When the moon is in another place, the tides are being pulled in another direction. When the sun and earth are on one side, they're pulling the tides very strong. As the earth turns around, it's the rotation also, with the sun and the moon, with the earth rotating, they're all having effects on the tides. That's why it's brought down in this question. It says base your answers to the question 66 to 69, but doesn't show anything about tides. And then asks you, explain why ocean tides are considered cyclic. The reason why they ask this question over here is because the earth and the sun and the moon affect the tides, including the earth's rotation helps affect the tides. And this is recurring. It happens over. Cyclic is a cycle. It goes round and round. So it's a cyclic is a recurring round of operations or events. The sun goes around, the earth goes around the sun in the whole year. As it goes around, the tides are being pulled in different directions towards the sun. The moon's going around the earth, let's say about 29 days or something, and the tides are getting pulled in that direction. So, question 67. Explain why ocean tides are cyclic. Well, what is cyclic? Cyclic is a recurring round of operations or events. For example, the earth, the sun, and the moon all affect the tides. The earth, the sun, and the moon affect the tides is because the tides get pulled in different directions because of the sun and the moon, depending on where they are. And the earth affects the tides because of its rotation. Now, one answer is tides occur in a regular repeating pattern. So that's called cyclic. So all you have to write for question 67, explain why ocean tides are cyclic. Cyclic means it's a repeating pattern, right? Cyclic is a recurring round of operations or events. So tides occur in a regular repeating pattern. That's your answer. All you have to write is tides occur in a regular repeating pattern. And what is cyclic? Cyclic is, but this is not the answer. Then asking you what is cyclic. If you want to know what cyclic is a recurring round of operations or events. But the answer to question 67 is tides occur in a regular repeating pattern. Question 68. How long does it take the moon to complete one revolution around the earth? Express your answer to the nearest tenth of a day. before we figure out if we're going to do till the 10th of a day, let's look at the solar system data chart we have. And I just wrote the beginning. You have, on the solar system data, you have an object, you have different planets, you have this, and all the way on the bottom you have Earth's moon. The first thing is the mean distance from the sun. After that is revolution, and there's a whole bunch of other things further down. So Earth's moon, it says period of revolution is 27.3 days. So to the nearest 10th of a day is very easy. 27.3 days. So you can just circle this answer over here. 27.3 days. Make sure that they see that decimal point, so they shouldn't think that's 273 days. So the answer to question 68, you look at your solar system data, you have the object, you go all the way down to the bottom object on that chart is Earth's moon, and first you look at mean distance from the sun. The next one is period of revolution, and you'll see on that chart, on Earth's moon, period of revolution is 27.3 days. Question 69. Explain why lunar eclipses only occur when the moon and sun are on opposite sides of the Earth. Well, what is an eclipse? An eclipse is when let's say a lunar eclipse is when the Earth is blocking the sun's light. So, and let's say you have the moon over here. So the light coming from the sun will not reach the moon because it will be blocked by the Earth. That is an eclipse. So the question is, question 69. Explain why lunar eclipses only occur when the moon and sun are on opposite sides of the Earth. The answer is because the moon must be in the Earth's shadow. That's your answer. The moon must be in Earth's shadow. So here's the sun's rays going in this direction. This part of the day, let's say the blue part of the Earth is where it's sunny. And over here it's dark. Now here's the moon. The Earth is blocking the sun's rays from the moon. So the sun is not going to light up the moon because the Earth is blocking it. So that will cause an eclipse. So again, explain why lunar eclipses only occur when the moon and sun are on opposite sides of the Earth. The reason is the moon must be in Earth's shadow. You can add to it that if the Earth is not in between the sun and the Earth, then Question 69. Explain why lunar eclipses only occur when the moon and sun are on opposite sides of the Earth. Well, this diagram, you could see it. You see the sun's rays coming, and you see that here's the Earth. Beyond it, it doesn't reach the moon, the light of the sun, so it does not light up the Earth. Question 69. Explain why lunar eclipses only occur when the moon and sun are on opposite sides of the Earth. The answer is the moon must be in the Earth's shadow. That's all you have to write. Now, if you see the diagram, I added on these things to show you. Here's the light coming from the sun. The Earth blocks, if this round blue thing is the moon, right? This is the moon. So it's not getting any light from the sun because the Earth is in the way. So that will cause an eclipse. Again, explain why lunar eclipses only occur when the moon and sun are on opposite sides of the Earth. It's because the moon must be in the Earth's shadow, which is over here. This is the Earth's shadow.